Hi there, Mr. Sutton here with the IM379 Extra Practice Solutions on cosine and sine. On this problem, we're trying to figure out the sine of 270. 270 is down here at the bottom of the unit circle, and for sine, we're asking about the y value at this spot, so that's going to be -1. For this problem, we want the cosine of pi over 2. That's over here at the top of the unit circle, and for cosine, we're asking about the x value here. Since that's on the y-axis, that's an x value of 0. On this one, we want sine of pi over 2. That's here at the top of the unit circle. And for sine, we want the y value, so that's a y value of 1. For this one, we want cosine of pi over 4. Let's convert that to degrees just to get a better sense of what we're looking at. So 180 divided by 4 is 45 degrees. And cosine of 45 is one of our special values. That is radical 2 over 2. For this one, we want cosine of 315. That's down here in quadrant 4. Now, the reference angle there, we are 45 degrees from the nearest x-axis angle of 360, 360 minus 315. Cosine, the x values, is going to be positive to the right of the y-axis. So this is going to be rewritten as positive cosine of 45, which is one of our special values. That's radical 2 over 2. On this one, we want cosine of 5 pi over 6. So let's convert this first to degrees. 180 divided by 6 is 30, times 5 is going to be 150 degrees. That's in quadrant 2 over here. Now, the reference angle, we are 30 degrees away from the x-axis, and cosine is going to be negative over here because x values are negative to the left of the y-axis. So I can rewrite this as negative cosine of 30. Cosine of 30 is one of our special values. That's root 3 over 2. So this then will be negative root 3 over 2. For this problem, we're trying to find cosine of 330. Now 330 is down here in quadrant 4. The reference angle, we are 30 degrees away from the 360 line, the x-axis, and cosine x values are positive to the right of the y-axis. So that means we can write this as positive cosine of 30 degrees, which is one of our special values. That's radical 3 over 2. To figure out sine of 4 pi over 3, let's first turn this into degrees. 180 divided by 3 is 60, times 4 is going to be 240 degrees. So that's down here in quadrant 3. Now the reference angle down there, we are 60 degrees away from the closest x-axis angle of 180. 240 minus 180 is 60. And sine, that's the y values, that's going to be negative everywhere below the x-axis. So I can rewrite this as negative sine of 60 degrees. Sine of 60, that's really radical 3 over 2, so this is negative root 3 over 2. To figure out cosine of negative 315, let's add 360 to make that a positive angle. So that's going to be positive 45 degrees that we're taking the cosine of. And we know cosine of 45 is one of our special values. That's radical 2 over 2, so there we are. For this problem, we want sine of negative 11 pi over 4. So this one's a little tricky. Let's convert this to degrees first. 180 divided by 4 is 45. And then what's 11 times 45? Well, 10 times 45 would be 450. So add another 45 to that, and you've got negative 495 degrees overall. Next, let's see what this is as a positive angle. So if I add 360, that's only going to bring me up to negative 135. Adding another 360 brings me to positive 225. Now 225 I know is here in quadrant 3. And the reference angle there, we are 45 degrees away from the 180 line. Sine is going to be negative down there because y values are negative below the x-axis. So this is going to be negative sine of 45. Sine of 45 is radical 2 over 2. So this then is negative root 2 over 2. For this problem, I want cosine of 5 pi over 2. Let's turn that into degrees. 180 divided by 2 is 90. 5 times that is 540. And let me just subtract 360 to see what angle we're really looking at here. So this is really 90 degrees that we're taking the cosine of. Now that's this angle up here, and we're looking for the x value. So that's going to be an x value of 0.